Dear friends, welcome to my video on what is quantum mechanics really all about. Kindly click on the CC button for subtitles. Quantum mechanics is a fundamental theory in physics that seeks to explain how the universe behaves at its smallest scales, typically at the level of atoms and subatomic particles like electrons and photons. This branch of science is vastly different from classical mechanics, which governs the movement of everyday objects. Quantum mechanics challenges our traditional understanding of reality with its unique principles and paradoxes, making it one of the most intriguing fields of study in modern physics. Wave-particle duality. One of the core concepts in quantum mechanics is wave-particle duality. This idea suggests that particles, such as electrons, can behave both as particles and waves depending on the experimental conditions. A famous experiment known as the double-slit experiment demonstrates this phenomenon. When electrons are fired through two slits, they create an interference pattern, which is characteristic of waves, but when observed, they behave like individual particles. This dual nature is mind-boggling and defies the intuition built from our macroscopic experiences. Superposition. Another striking feature of quantum mechanics is the principle of superposition. This concept means that a quantum system can exist in multiple states simultaneously until it is measured or observed. One of the most well-known illustrations of superposition is Schrödinger's cat thought experiment. In this scenario, a cat inside a box can be both alive and dead at the same time until someone opens the box to observe its state. While the thought experiment is theoretical, it highlights the bizarre nature of quantum systems where multiple outcomes can exist simultaneously. Entanglement. Quantum mechanics also introduces the concept of entanglement, a phenomenon where two or more particles become linked in such a way that the state of one particle instantly influences the state of the other, no matter how far apart they are. This spooky action at a distance, as Albert Einstein called it, suggests that information can travel faster than light, which contradicts classical physics. Entanglement has real-world applications in emerging fields like quantum computing and quantum cryptography. Uncertainty principle. At the heart of quantum mechanics is the Heisenberg uncertainty principle, which states that it is impossible to know both the exact position and momentum of a particle at the same time. The more accurately you know one, the less precisely you can measure the other. This inherent uncertainty is not due to limitations in technology but a fundamental aspect of the quantum world. It challenges the deterministic view of reality held by classical physics, where, given enough information, the future can be predicted with absolute certainty. Quantum mechanics in everyday life. Though quantum mechanics might seem abstract, it plays a crucial role in modern technology. Devices such as smartphones, lasers, and MRI machines rely on quantum principles. In addition, quantum mechanics is foundational in the development of quantum computing, which has the potential to revolutionize industries by solving complex problems far more efficiently than traditional computers. In conclusion, quantum mechanics is really about understanding the counterintuitive and mysterious ways in which the smallest components of our universe behave. From wave-particle duality and superposition to entanglement and uncertainty, quantum mechanics reshapes our understanding of reality, offering a glimpse into the complex and fascinating nature of the universe at a fundamental level. Thank you for watching my video. Kindly subscribe to my YouTube channel and give a thumbs up. Thanks for your support.